Similarities and enlargement. We start with similarity. Now there are so many things in nature that are similar, but in mathematics similarity is only used to mean same shape but not necessarily same size. As long as the shape is exactly the same, the figures are said to be similar. So in such cases, all circles, equilateral triangles, squares, rhombus and all regular polygons are similar. For figures to be similar, the ratios of corresponding sides are constant. For example, consider these two triangles on your screen. If the two triangles are similar, the ratio of the corresponding sides is constant. That is to say, AB over A prime B prime is equal to BC over B prime C prime and is equal to AC over A prime C prime. Equally, angle ABC is equal to angle A prime B prime C prime. Angle ACB is equal to angle A prime C prime B prime, and angle BAC is equal to angle B prime A prime C prime. Now notice that the angles are equal but are not in ratios. We shall not dwell so much on similarity. We will move to the all-important area, that is enlargement. When an object or a figure increases or decreases in size, we say that an enlargement has occurred. Wait, even reducing in size? It is just that the scale factor is less than 1, that is a proper fraction. For instance, a figure enlarged by a scale factor a half will reduce to half of its original size. The original figure is the object and the enlarged figure is called the image. So conventionally, the image is represented with primes. For example, object PQR, its image is P prime Q prime R prime. So look at this enlargement on your screen. Triangle ABC has been enlarged twice, first to triangle A prime B prime C prime and then into A prime prime B prime prime C prime prime. When the dotted lines touching the vertices are produced, they converge at O. The point O is called the center of enlargement. The ratio of the scale is constant, that is AB over A prime B prime is equal to BC over B prime C prime, which is equal to AC over A prime C prime. Now this ratio is called the scale factor. Now also, the ratio of the distances from the center of enlargement to the object to the distance to the image is constant. That is to say, the distance OA over OA prime is equal to OB over OB prime and is equal to OC over OC prime. The scale factor is given by linear size of the image over the linear size of the object, or image distance from the center of enlargement over object distance from the center of enlargement. Notice that both object and image distances are measured from the center of enlargement. Now a common mistake by students is to measure the image distance from the object. It is wrong. Now let's see how we enlarge objects. Enlarging objects is very simple. It's very simple. So in order to enlarge an object, we must have the scale factor and know the center of enlargement. The key thing to note in enlargement is that distances are measured from the center of enlargement only. Only from the center of enlargement you measure the distance from the image and from the object. Now for example, I have my triangle XYZ. I want to enlarge the triangle here by a scale factor of 2 with O as the center of enlargement. Now it's very simple. It's a very simple procedure to follow. Now enlarging it, we draw a line OX, a line from the center of enlargement to the x, that is the vertex of that triangle, and then I will produce that line. I will then repeat the same for OY and then join again OZ. I have those lines. Now I will measure the distance OX. I measure the distance OX. I want to enlarge the figure by scale factor 2. I measure the distance from the center of enlargement to X and then take twice that distance. So again, I measure the distance from O. So I will have my X prime there. Now my new point OX is here. So again, I take the distance OY and then double that distance. So I have OY prime. So my Y prime is here. Finally, I measure the distance OZ and then take twice that distance, and I will have my Z prime. So I have all the vertices of my image, and all I need is to complete my figure so that I have this, and that is my image. Let's do that again. We have triangle XYZ. We want to enlarge it by a scale factor about the center of enlargement O. So the procedure is simple. We join O to X and produce the line. And then we repeat the same with Y and then Z. We have the lines OY and OZ. Now we want to enlarge that triangle by scale factor 2. So we measure the distance OX and then take twice that distance from O. Always measure from O. So we take twice that distance. We will have our X prime. We measure OY, take twice the distance. We have our Y prime. Finally, we measure OZ. Again, double the distance and we'll have Z prime. Only notice that I'm measuring the distances from the center of enlargement, and finally I complete my triangle to make the image. The next thing is locating the center of enlargement and finding the scale factor. Now suppose you are given two similar figures, one larger than the other. You can find the center of enlargement, and once you get it, you can calculate the scale factor. Now we have two triangles on your screen. These two triangles are similar. Triangle ABC has been enlarged to A prime, B prime, C prime about a center of enlargement which is unknown to us. Now to locate the center of enlargement, we simply do the following. Again, it's very simple. It is just the reverse of enlargement. Now you will join point A and A prime and produce that line. Next you will join B and B prime and again produce the line. Now the point at which the lines converge is the center of enlargement O. The point at which the two lines converge is at point O, which is the center of enlargement. You actually don't even need to join C to C prime because it will converge at the same point Y because the two figures are similar. Now to get the scale factor, you measure the distance OA and then you measure OA prime. The scale factor is given by OA prime over OA. Again, we repeat that. We have two similar figures here, A, B, C and A prime, B prime, C prime. We want to find the center of enlargement. We want to find the center of enlargement and the scale factor. To do that, we said you join the corresponding vertices and produce the lines. So join A to A prime and produce it. join B to B prime and again produce it. The point at which the two lines converge is the center of enlargement. Now to find the scale factor, you divide the image distance over the object distance. You can take OA prime over OA or OB prime over OB, it doesn't matter. Now notice that when the scale factor is greater than 1, the image is larger than the object. If the scale factor is less than 1, the image is smaller than the object. Now let's look at a negative scale factor. Now for the enlargement that we have done, both the image and the object lie on the same side of the center of enlargement, and this is a positive scale factor. For a negative scale factor, on the other hand, the object and the image are on the opposite side of the center of enlargement. Do not confuse the negative scale factor and fractional scale factor. A negative scale factor greater than 1, say -2, will increase the size of the object twice as much, while a negative fractional scale factor of say -1/2 will reduce the figure by half the original. Let us enlarge triangle PQR by a scale factor of -1/3 about the center O. The important thing to note is that the scale factor is a negative, and therefore the object and the image will lie on the opposite side of the center of enlargement. It is a fractional scale factor, and therefore the image is smaller than the object. The procedure is still the same. Now the first thing I'm going to do is join P to O and extrapolate that line. I do the same with Q and extrapolate that line. And finally, I join R to O and extrapolate that line. Now I'm going to measure the distance PO and then take a third of that distance along the extrapolated line and measure that distance from O, not from P. From O, I take a third of PO because the scale factor is a third. So if I had 9 centimeters, I will measure 3. So I have my P prime. I then measure QO. I take that distance and then take a third of that along the extrapolated line from O, and I have my Q prime. Finally, I measure RO, take a third of that along the new extrapolated line, and I will have my R prime. So I have all my vertices, and all I need now is to join them, and I'll have my image P prime, Q prime, R prime. Now what we have now is the image of PQR enlarged by a scale factor -1/3 about the center of enlargement O. Now notice the following, that the image is smaller than the object. In cases of negative enlargement, the image is inverted and on the opposite side of the center of enlargement as the object. This is the same procedure that you follow when enlarging figures on the Cartesian plane. The only difference being that you shall be given the coordinates of the vertices of the object and the image and those of the center of enlargement. The procedure is the same, you just draw straight lines and take accurate measurements of the distances. Now let us look at area and volume scale factors. Area and volume scale factors. We have seen that the linear scale factor is the ratio of the length of a figure. If two figures are similar and we know the area of one of them and the linear scale factor, we can find the area of the other using the relationship area scale factor is equal to linear scale factor squared. We then multiply the area of one figure with the area scale factor to get the area of the other. For example, two triangles are similar with bases 5 centimeters and 15 centimeters. If the area of the smaller one is 32 centimeters squared, find the area of the larger one. Now in the solution, from the length we can get the linear scale factor, that is 15/5, which gives us 3. Now the area scale factor is linear scale factor squared, so we have 3 squared giving us 9. Now the area of the larger triangle is equal to area of the smaller triangle multiplied by the area scale factor, which will give us 32 times 9, which is 288 square centimeters. 288 square centimeters, that is right. The same case follows when it comes to volume, and volume scale factor is given by linear scale factor cubed. For example, two similar spheres A and B have radii 6 and 12 centimeters respectively. If the volume of B is 64 cubic centimeters, find that of A. Again, in the solution, we first find the linear scale factor. We shall have 6/12, which is a half. The volume scale factor is linear scale factor cubed, so a half cubed gives us 1/8. The volume of A will be given by volume of B times the volume scale factor. So volume of B is 64, we multiply by 1/8 to give us 8 cubic centimeters. A has a volume of 8 cubic centimeters. Now it is important to note that the scale factor need not be a proper fraction or a whole number for that matter. For instance, in the last case we could have as well done like this. The linear scale factor, we can make it 12/6 instead of 6/12, which will give us 2. Hence the volume scale factor will be 2 cubed, giving us 8. Now you need to notice that the linear scale factor was obtained by dividing the radii of the larger sphere by that of the smaller one. So the larger volume will be given by small volume times the volume scale factor. So 64 cubic centimeters is the volume of the larger sphere, will be given by the small volume, which we don't know, times the volume scale factor, which is 8. If you divide both sides by 8, you will have the volume of the smaller sphere given by 64/8, which is 8 cubic centimeters, the same as the one we got.
You can always spot the brightest minds, the ones who think bigger, who push concepts a little further. When you combine theory with practical study, you get university students that are more switched on. That's why Curtin graduates are ready to make a difference from day one, to help make tomorrow a better place.